Once again, I'd like to thank you for joining today's webinar. My name is Tony Williams. I'm the Market Segment Manager for our microfocus product lines globally. I will be joined by Dirk Schneider, who is our Product Manager for our open microfocus systems. All right, first some words about Comet. We have our corporate headquarters in Flamatt, Switzerland, and we manufacture, market, and sell metal ceramic X-ray tubes and generator sets for non-destructive testing of materials worldwide. The metal ceramic X-ray tubes and generator sets are used in the transportation market, transportation being aerospace and automotive, as well as in electronics, pipeline inspection, and also for security inspection of baggage and cargoes at ports and also at airports and border crossings. Our open microfocus X-ray technology is largely used in a lab environment or at line for feature detection and metrology of defects at or below 25 micrometers. However, it does span a broad range, so it can be used for larger than 25 micrometers, but within our product portfolio offering, that is where we target our open microfocus products. My colleague, Dirk Schneider, once again, the product manager for these X-ray modules, will take you through the technical aspects and cover some initial applications where it is viable, the product is very viable, and you'll see that you're really limited only to your imagination. All right, at this point, I'd like to introduce my colleague, Dirk. Dirk, will you join us, please?
Yes, thank you very much, Tony, for the introduction about what Comet has done in the past and is continuing to do. And I would like to take us a bit more into the current product lines that we have available before we dive deeper into the FXE series, which you see here on the left side. Comet has set itself up as a one-stop shop, so we are committed to deliver everything that's needed around X-ray generation. Traditionally in the minifocus regime, and now since recently also tapping into mesofocus and microfocus regime. So on the left, as I said, the open microfocus tubes, the FXE. Next to it, the mesofocus, that there's a 225 kV version that was launched this year. What you see here is a 450 kV will be available next year. On the right, the high power series has been around for a couple of years and is heavily used in a number of NDT applications. And next to that, the extra performance series, also only recently available with an extra filament so that you can maximize your uptime. The Evo series, second to right, is a well-known and well-established mobile system was most heavily used in pipeline applications. And on the far right, an integrated module that is the Ion series that is used in security applications in larger numbers. So let's have a deeper look at the FXE. They come in two flavors. One is the transmission module, the other the reflection. And the transmission modules that you see here, they feature very high magnification, and that is because they use a transmission window. So the X-ray generation takes place in the window itself. That means the focal spot to object distance is defined only by the thickness of the window. And along with that, it comes also a high resolution. So you go down to 0.6 micrometer with our nanofocus tubes. And also these targets have high power capability because they're based on a diamond substrate. So you get out the heat quite quickly. All these tubes that you see today here in the FXE tubes, they are designed as open tubes. And the reason for that is that we want to run the tubes at their physical limits, meaning also we will burn at some point a filament or wear out a target. So you can replace these parts, thus rendering the tube basically living forever. So you can extend its lifetime by replacing parts. Due to that fact that you replace parts once in a while, and also that you need to have the occasional calibration of the active focusing part, it is well suited for a lab or an at-line inspection where you have the calibration time available at some point, not so much for an inline application. But anywhere where you inspect small parts with tiny features, or even want to measure them, they are a great choice. And the reflection modules on this side, they are available up to 225 kV. That's what you see on the right. And they have due to the fact that they have a higher voltage than the transmission ones as of now, they give you better sample penetration. That's make them better suitable for CT. They also have a large resolution range, so from down to 4 micrometers up to several millimeters. They are quite easy to use for that, and that is a big strength together with a high power capability. Just as a transmission tube, they are also designed as open tubes, so you can replace any wear part with ease, and we will get to the details on that when we talk about our support setup. As I mentioned, this tube is in particular suitable for 3D inspection due to the high power and penetration, and also, of course, for small parts in the microfocus range, and for an at-line or lab inspection environment. Before we have a deeper look at the applications and how the product are positioned within our portfolio, I would like to take us into the distinct advantages of the tubes. For a microfocus tube, first and foremost, that's of course the high resolution. So we say roughly half a micrometer, this is where it can end up. And that again, highly depends on the system settings. So you can optimize that to go to 500 nanometers and even below. But that also depends on detector and how you set it up. We can go to the details in a separate call if you wish to explore that further with us and really to test the limits. And how is that achieved? That is because we have 2 focusing stages here to really narrow the beam down to that small size in the nanofocus mode. But this second focusing stage also helps you to optimize the nanofocus tube for high power operation to let more electrons through at a higher power level. That means you would have a larger spot, of course, but also more flux available, which would allow you to take the images quicker at a higher power level. Next one would be the stability of the tubes, the consistent image quality. So you have an inherent stability by design already, but in the way we operate it can take this even a bit further. We have the so-called the TXI, the true X-ray intensity feature, which is basically a target current control. So instead of controlling the emission current, we control on the target current, which cancels out all influences that could appear between generation of the electrons and then accelerating and focusing them and so forth. So that is a great feature if you run long scans in CTs. Next one, the high power density. Compared to a sealed tube, an open tube will allow you to really go to the physical limits. You can run the targets and the filaments at the maximum what's possible, and thus get the highest possible flux at a given focal spot size. And that allows you to be quick despite the fact that you have a very small area of emission that is needed for microfocus imaging. But that's also not a problem, because thanks to the open nature, you can replace those parts whenever they wear out. The lifetime of each of those parts will highly depend on the mode of operation, and sometimes hard to predict. Once you have the settings and use it all the time, then you will see this is my average lifetime. And typically they span from 100 to 500 hours. And yeah, mentioned already the open nature, and to maximize throughput, you will run at the limits, but that means you need to replace it at some point. We are committed to make this as easy as possible, and we have done already, and we'll think more what else can be done here to make the life as easy as possible for the operator. As you can see here, you can just fling open the tube and take out the cathode tip that holds the filament, for example, that can be easily replaced. And there are many other parts like O-rings and targets that wear out. These are the main parts that wear out, but in principle, any part can be exchanged. You don't need to buy a new tube, which renders the cost rather low in the long run. So having said that, I would like to give you an overview of the modules that are available today. In the middle, you see our microfocus transmission tube. They have a single focusing stage. They have a high power target and a wide beam, 470 degrees, which gives you a large field of view. And on the left side, you see our nanofocus tube. It also has a high power target and the wide beam, and allows you to go down to 0.6 micrometer. GMA resolution is that. And on the right side, you see our reflection module with beam powers up to 300 watts. And as mentioned before, resolution starting at 4 micrometer up to millimeters. All right. Yeah, after that quick introduction, I would like to give back to Tony and explain the service and support model that we have picked. Yeah, please, Tony, over to you.
Okay. Thank you, Dirk. Thank you for taking us through the features of the FXE products. Our support organization, let me first tell you a little bit about us. We are, as I said earlier, we're based in Flamatt, Switzerland. That is where our corporate headquarters and global support center is located. However, we're very regionalized. So within each region, in Asia, in North America, in the United States, and in Europe, we support each region out of our regional centers. And what does that mean? That means that in those regional centers, we have spare parts, we have a technical support team all ready to support the OEMs and our partners, right? Those are the people who sell and service the equipment to you, the end user. So how does it work? The way it works is that if an end user has an issue or needs to know how to do something, or is having any type of questions or concerns, for example, how can I help to extend my filament life or anything like that, their first point of contact is the OEM. So you reach out to your OEM or service partner. They are trained and certified by us. All of our OEMs and partners have to undergo a certification program. And that's a lengthy program in which we conduct training in-house at our facility or at the OEM facility. And we train on the equipment that we sell. They learn not only in installation and commissioning, but also troubleshooting and maintenance of the product. At the end of the training program, there is a comprehensive examination that all have to be able to pass, that shows that they understand and can communicate the knowledge of the product, how things work, and how to fix things, right? They then receive a certificate. The certificate is valid for 2 years. The reason for 2 years is that we intend to do minor as well as major product fixes and changes to the product to improve performance over time. So we want to make sure that all of our OEMs come back, get recertified, learn all of the latest and greatest things so that we can provide the best performance and support to you, the end user. If for any reason the OEM requires any type of assistance, they can contact our regional support, technical customer support team that's ready to support them, whether over the telephone, answering emails, or if the end user allows, we can actually do remote diagnostics directly to your tool. However, once again, I would like to reiterate, we cannot do that unless you agree to that. So it's not something that we can just do on our own. We require your approval and support to be able to do that, but we would be able to see firsthand the type of issue that you're having and be able to help our OEM service representative solve whatever problem you have. If for some reason our technical customer support team encounters an issue that they have not seen before, or something that is so infrequent that they may not be skilled upon, then they would rely on our global technical customer support team, Inflamat, to help them with assistance in answering any and all questions and concerns. Our global technical customer support team is extremely knowledgeable and has access to our manufacturing engineers, as well as the engineering R&D team that develops the product in case of any occurrence in which we cannot handle within the region. So once again, the end user contacts our OEM and or certified service partner, who in turn provides them with firsthand support. We, Comet, in turn, out of our region, supports the OEMs directly. And that's the same way that we're structured from a service standpoint. All of the, what we call emergency spare parts, are parts that wear, such as that the filament and targets and O-rings that Dirk mentioned. Those are all housed within the regions. So if the OEM needs spare parts while their service engineer is on site, it can be ordered directly from the region and can be there same day or next day, depending upon the location of the end customer and delivery systems that are available within each region. So that is our customer support in a nutshell. We're here to support our OEMs and partners, who then in turn provide world-class support to you, the end user. I hope that clearly explains our support structure from both a technical perspective as well as in terms of inventory. Dirk, back to you.
Thank you very much, Tony. And before we go deeper into what typical applications we see for the FXE, I would like to give us an overview of how the FXE series is positioned within our portfolio. When you look on this slide, what you see here, that's a logarithmic scale of the resolutions, and we put our product series on that graph here. On the top right, you see our Nanofocus series, the oldest product line that we have, and that's still very actively used, serving 75 to 600 kV, and with a resolution range down to 200 micrometers. And that also there's a special product, the Nanofocus, that has been around for a while that can reach a bit lower than that. And now recently, as mentioned earlier, we have launched our Nanofocus series, shown here as a 225 kV. The 450 will be available soon. And the Nanofocus covers 25 to 130 micrometers. This is a sealed tube, so no open tube, so it's really suitable for inline applications. And it will run its lifetime until it then needs to be replaced, but it will really give you a high uptime. Below that is our microfocus sealed module, microfocus sealed series. This is not yet on the market. Just here to announce that next year we will launch it, and we'll start with 130 kV modules, and we go down to 5 micrometer resolutions. But we're here to talk with you about our open microfocus ones that you see at the bottom, and you already see the big benefit here is a large focus range. So down at 0.5 micrometer with a nanofocus tube up to several hundred micrometers with our reflection tubes. This is the range that we cover. And since there are so many products and everyone has some advantages, and it's always a challenge to find out what is the best for my application. And that's why we have created these spider charts for the communication with our OEMs, but also they can use it then when they talk with their end users. To somehow show the distinct advantages of each tube and how it's positioned within our portfolio. You see the different shapes here, and this next slide is to explain that a bit further. We start always with a resolution, which we think is the defining feature of the tube, or the most important one. So as you've seen before, we structure by micro, nano, or nano, micro, meso, mini. So let's check first what resolution is needed. Next one will be the penetration. So how dense are the materials that I want to look at? What is the right kV that we need? The third in line would be the throughput, which equals power and hence the speed of my machine, of my line in the end. And at the bottom, you see uptime. So here we rate the capability of the modules to run 24/7 without interruption. The next one, the easy care, is to what extent do I need to do the maintenance, or how easy is it? And that's that dimension. And the last one is the compactness, the footprint or the size. The smaller the module gets, the larger score we will see here. When we look at this slide, we show it here as an example for our microfocus products. So starting with the Nanofocus on the right, you can see it's like it has some good or average rating on all those dimensions. So it's really trying to combine both the ease of a sealed module with the low resolutions, with the high resolutions and small focus spots. And that really makes it suitable for inline inspection. That is the main strength here, and stability and low maintenance, of course. When you look to the left of it, you see the FXE reflection tubes. They have some overlap with the Nanofocus in terms of resolution, but they actually reach far lower spot sizes, to see smaller things, basically. So they have a great resolution range, which we don't really rate on these dimensions. And also it has a higher magnification. That is a clear advantage over the mesofocus. But due to the open nature, is more suitable for a lab on at-line inspection environment. Same as the transmission tubes, and here the defining feature is the high resolution. So that is the only product that yields a 5 on the resolution dimension. All right, so this to introduce our products, the FXE, and how it's positioned in the overall portfolio. Next, I would like to take us into the typical applications and explain a bit further where we see it used today, and to make sure you understand the potential and maybe even see more potential in that. Okay, the first one and by far the most intense use that we see right now for the transmission tubes is in the electronics inspection field, and here we typically look at PCBAs, at the soldering joints, at BGAs, at bond wires, but also wafer level packaging. So it's really diverse, and with down to half a micrometer, you can cover a lot here. The next one will be the field of medical or pharmaceutical manufacturing, but also preclinical studies, tissue imaging, and all that. But also medical implants are quite important field because you also get good contrast here. In dentistry it's used, and in pharmaceutical manufacturing, quite often you see it in the inspection of packaging material and things like syringes, capsules, all these, the spring here in the spray that you see on the right side, as really diverse applications. Another one, and a hot topic of these days, electric mobility and battery inspection in particular, but also power electronics. But battery inspection is quite a big one because here the safety of operation is quite crucial, and manufacturers want to do anything possible to make sure they are manufactured to specs. So what they look at typically is the anode tilt or anode overhang, and also make sure there are no inclusions, no gas inclusions, no particle inclusions that could somehow cause a short circuit or thermal runaways and so on. That is a big application. The next one is a more traditional field, the big field as well, entire aerospace and automotive, like turbine blades is what we see, but also any other part that's like a cast titanium or aluminum, airbags I mentioned here. There is again quite diverse, but nonetheless very safety relevant, and that's why we see inspection of with microfocus tubes quite frequent. And another one that is still rather new compared to the more traditional ones is the additive manufacturing of 3D printing. Here you can create very complex parts, also composite materials. And while traditional methods of ultra optical or tactile measurements might fail here because you create more complexity, you rely on X-ray inspection to make sure these parts are manufactured according to specs, according to schemes, and that is what we also see as becoming more and more important. And at last, there might be more applications. Definitely, there are more, and as Tony initially mentioned, you're only limited by your imagination here. Over the years, we have seen more and more X-ray applications, and we don't stop to be amazed at what our customers and end customers are doing with our products, and it's quite quite interesting. And that's why we would like to get in touch and hear about your ideas and see what can be our part in that to solve a problem or an upcoming problem that you see. And the typical environments for these tubes would be an R&D lab or any at-line production quality control, where you look at sizes of defects or features smaller than 25 micrometer. Some examples could be like solar cells, also geological samples. It's really diverse. So if you have something in mind, please contact us, or if you're an end user, contact your OEM and try to find out more about what would be possible and what not. So with that more generic introduction into the fields of application, I would like to hand back to Tony and ask him to give us some deeper insight into specific inspection tasks. Please.
Sure. Thank you, Dirk. Certainly sounds like a good tool for applications from low density to high density, you know, whether the parts are thin or thick. So if we look at some applications specifically, right, so in 2D radiography of electronics, you see a lot of inspection of solder joints. The critical solder joint components tend to be things like flip chips or BGAs, micro BGAs, column grid arrays, through-hole components, you know, a wide variety of different types of components need to be evaluated. So there's a lot that you can do with X-ray. Here are just some examples that we have here in which we have the transmission X-ray tubes collect and enable the X-ray system to collect these types of quality images. And through image enhancement software, you're able to clearly see defects. So if we look at these images here, all 2D images, we can clearly see that you have BGA with voiding. Here we are showing through-hole components. And then down here is a deeper look at these by going to higher resolution and limiting our field of view to just the components of interest. And you can see that there's quite a bit of voiding that's occurring within the solder. And then here on the lower right, we have a leaded component in which you can see that there's some misalignment of a very small component here. Here in this example, it's a 3D example, 3D using laminography versus cone beam. In a lot of the electronics systems that are available in the electronics marketplace, you see a lot of laminography because it can be faster than cone beam and give you a lot of the similar information. So in the top here, what we can see is that we are seeing a projection in the top two images here, projection, and we're seeing voiding occurring, and that's what we're seeing here. And if we look at it through using more volumetric enhancement software, we can clearly see the voiding. And if you wanted to do classification of the voids in terms of things like sizing, counting, excuse me, or any type of metrological measurements, you would be able to do that with the software, either the software provided by the manufacturer of the system or software through a third-party vendor. Here are some 3D images. So what we have here is the raw X-ray image where we're looking at 2D. And then we have it here with, once again, a laminography slice where we're looking at the CT image of that. And down here, it's processed so we're able to clearly see the wetting of the component, right? So here are the ball grid arrays and how well is wetting of the component. So if you get 100% wetting of the balls, that's what you want. If you have insufficient wetting, then you can create what's called a head and pillow scenario, where you end up with not enough wetting of the ball. You may have just enough for electrical connectivity, but for long-term material, physical stability of the component, right, for mechanical strength, it's insufficient due to that head and pillow effect, which can create failures. So you need to be able to detect them early on, as opposed to once the product has gone out the door. Today, what we have here is a 2D image of a microbump, right? And it's a 60 micron IC microbump. And what we have here is after using some processing software, we're able to see that you have a gradual worsening of the bonds within the microbump. So that would be indicative of impending failure. So once again, the X-ray tube allows you to be able to detect these features, and then through the X-ray software, you're able to go in depth and classify your defects. Here we're showing the 2D image of micro BGAs, and you can see some voiding in the image. You take a laminar graphic slicing of those images, and you can see the voiding in more detail and better understand what is going on to be able to make correction within your process. These now moving right along are examples coming out of our reflective targets, or 225 kV open microfocus reflective target tube, so our FXE 225. And here we have images of aluminum parts. And as you can see here, there are clearly some defects going on. You could look at this take a higher resolution, change and get closer and examine what's going on. Or you can certainly look at these images in 3D. I should say that we've got the images courtesy of both Epsilon and Wari, so I do want to give them credit for that. Thank you very much. Here are some 3D examples, and what we're showing here not only are 3D slices, and where we've done volume, where we have generated a 3D volume and then done some reconstruction, is we've incorporated some metrological measurement software. Some of these software packages are available from a variety of different companies. You have products from Volume Graphics as an example. VG Studio or VG Studio Max will enable you to do these sort of things. Object Research Systems with their product called the Dragonfly will also allow you a lot of these measurements, as well as Thermo Fisher Scientific. Their package Viso will also allow for these types of measurements, and there are other third-party packages, along with packages that your CT provider may also provide. But here we're showing wall thickness measurement of the piston, and here in the bottom we have a cylinder head. And what we're showing in the cylinder head here, what's interesting is we're showing how well is it manufactured in comparison to the CAD. So that's called a nominal actual comparison. And here we have a bar graph on the left. Everything in green shows that it is manufactured according to specification. If you see blue, like here or here, it shows that in these areas, it's slightly below specification. And if you have any red or pink, what that's denoting along here is that it's above or outside of your specification. So once again, what the X-ray tube does is that it allows you to collect a very clear image, and then the software of the X-ray and CT system allow you to be able to do various morphological classification as well as metrological measurements, and clearly show whether the part is good or bad. These are some additional examples taken with the 225. On the top, we have fossil samples. So this is colorized versus black and white, just the overall volume here. That's not colorized. And below, we have some owl pellets. Here you have colorized images in terms of separation that we have going on. So this, once again, is possible because you get a very good contrast image using our X-ray tubes. They're highly stable, as Dirk has mentioned, for the stability and the true X-ray intensity. That stability allows for long-term scanning if you need to do whether short CT scans or long CT scans of several hours. You're able to do that with our tubes. And then the X-ray system and CT system have software that enable you to do a lot along the lines of morphological classification as well as metrological measurements. At this point, we're done with the examples that we have. I'd like to turn it back to Dirk to summarize the benefits of our microfocus products, and then we'll take your questions. Once again, I'd like to remind you to please use the Q&A function to ask all of your questions. Please do not hesitate. There's no question that is too small or, well, it must be understood by everybody. Please feel free to ask any questions that you have. Dirk, back to you.
Thank you, Tony. That was quite exciting to see those application examples. And I'm sure there's a lot more, and I'm looking forward to see more when partnering with our OEMs and also new players. So thank you for that. As Tony mentioned, we would like to go over to the Q&A, but before we do so, I'd like to quickly summarize what we've seen today. We looked at the portfolio of FXE modules that we have available today, and they feature high resolution inspection and measurement of complex parts. That's what they enable you to do. And they're all highly stable and made for also longer CT scans and also repeated scans with the same imaging outcomes. They're designed so that you can replace wear parts easily, but also keep the cost low at the same time. Yeah, have some advantages here compared to your seal tubes. And also Tony expanded on our support organization. What are we doing to support our OEMs and to make sure the end user gets the best possible service? And we think this really puts us ahead of our competitors. We think with our presence in the regions, we really make a difference here. What I've shown is what we have available today, but that's not where we will take a rest and stay. We are continuing to developing the products. We're looking into future requirements. We're looking into the pains that are present today and come up with solutions to improve. And one of the more tangible ones, which I would like to announce here, is the 190 kV transmission module. It's a highly stable nanofocus tube, and that will be available around middle of next year, 2022. So with that, I would like to close our presentation and go over to the Q&A session.